Welcome back to my channel. In today's video, I'll be discussing how to solve a linear differential equation by using the integrating factor. So let us now come to this thing. So this is the general structure of a linear differential equation. Here we can see that here the highest order derivative is 1, and this is not only linear differential equation, this is linear differential equation of order 1, as the highest order derivative here is of order 1. So this term here, it has power 1, so this is of order 1, and this is linear in the sense that y has highest power 1, dy dx has highest power 1, and there is no multiplication term between y and dy dx. So here, and these coefficients may be constant or they may be a function of x. So let us now see some examples. Suppose we have a problem dy dx plus xy equals to say tan x. This is a linear differential equation. Another example, let us write it like this: dy dx y sec square x equals to tan inverse x. So this is linear in y. There is another thing which is linear in x. So I will come to it later. Now integrating factor. So integrating factor and exact differential equation are very much related. So suppose we have a linear differential equation of this form: dy dx plus say px into y equals to qx. So if we can write this left hand side as some function of, say, I'm writing it as g of xy equals to qx, where g of xy is some function of x and some function of y. So if we can write this as this form here, then this differential equation will be called an exact differential equation, and by integrating we can always obtain the solution. Now the differential equation may not be in the exact form, but there are certain functions, if we multiply the differential equation by that function, then that equation will become the exact differential equation. So suppose we have a function like this one here, and we multiply it pxy into some integrating factor qx into integrating factor, then this differential equation, if we put it in this form, then it can be written as this: d of xy ddx of some function of xy, as the integrating factor is a function of x or a function of y or a function of both x and y, and qx into integrating factor. Then by integrating we can obtain the solution easily. Now let us see what is the integrating factor for the linear differential equation. So we have this linear differential equation ddx dy dx plus px y equals to qx. So in this case the integrating factor is e power integration px dx. Okay, so if we multiply both sides, so here obviously the integrating factor is a function of x. So if we multiply both sides with this integrating factor, then we will obtain dy dx into e power integration px dx plus px y into integrating factor equals to qx into e power px integration px dx. So see, it can be written in this form, d dx of y into e power integration px dx equals to qx into e power px dx. So see, this function here, this one can be written as the form d dx of some function of xy equals to some function of x here. So if we now integrate this, we will obtain the differential equation. So before integrating, let us check one thing, d dx of this function here. So there is a multiplication between two functions, so derivative will be like this. So first we can differentiate this function y, and that will become dy dx into this function will be as it is, plus there will be y into derivative of this function here. So derivative of this function, this is e power function, so e power function will become like this, and next the derivative of the integration term, so d dx of integration, so dx will get cancelled out and d and integration will get cancelled out, and it will become only px. So this term here, this whole term here is obviously the derivative of d dx of this term here. So now we can integrate and obtain, so it will become y into e power px dx equals to integration qx e power px dx plus c. So this will be the integrating factor, this will be the solution of the linear differential equation. Now as I have said earlier that this is linear in x and this is linear in y, and there may exist some solution, there may exist some linear equation which are linear in x. So those equations are of the form dx dy plus py into x equals to qy. Okay, so the solution of the integrating factor in this case is this e power py dy. This is integrating factor, and the solution will be this form, x into e power integration py dy equals to qy into integrating factor py dy, and there will be another integrating factor, there will be another integration, and it will become like this. Also there should be a dx here. So this one here is the solution of the linear differential equation in y, and this one here is the solution of the linear differential equation in x. Now let us solve some problems. So we have this problem here, x into dy dx. So this is not in the linear differential equation form, but we can put it in that form. So it will become dy dx plus 1 by x log x plus y equals to 2 by x square. So we are dividing both sides by x into log x. So the px function, if we compare with the standard form, the px function here is 1 by x log x, and the qx function, after dividing, it will become, if we divide here, this will be 2 by x square and log x will get cancelled out. So here the integrating factor is e power integration x log x dx. Okay, so how can we integrate this function? So we can do it like this. It will be, if we substitute log x by z, it will give 1 by x dx equals to dz. So e power integration, so dx by x will become dz, and 1 by log x, it will become 1 by z. So it will be like this, and ln z, so this will give z. This means log x. So in this case, log x is the integrating factor. So if we multiply both sides of this equation by log x, both sides of this equation, this one, as this is in the standard form, we multiply both sides of this equation by log x, then we can easily obtain the solution. So I am directly writing the solution as this form here, this form. So if we directly write the solution of this equation, so we will obtain, it will be y into log x equals to, so it will be this y into log x, and this side it will be multiplied by log x, and then there will be an integration. So it will become 2 by x square log x, and there will be integration dx. So y log x. Okay, so now integration of two functions. So we need to use the formula. So what will be the formula? It will be like this: integration uv equals to uv minus integration dd x of u into integration v, and there will be the whole integration. Okay, so as we do not know the integration of log x, we will use it in the derivative. So it will become 2 into log x integration 1 by x square minus, so the derivative of log x is 1 by x, and again integration of 1 by x square dx, and there will be another dx here. So 2 into, so integration of 1 by x square, integration of x power minus 2 becomes x power minus 1 by minus 1 plus c, obviously. So it will become minus log x by x minus, so there is 1 by x, and there will be another 1 by x along with, it will become plus c. So the ultimate solution will be y log x equals to 2 into minus log x by x, and this is again minus x power minus 2. So this integration will become minus 1 by x plus c. So the ultimate solution is in this form: y log x equals to minus 2 by x 1 plus log x plus c. So this is the solution of the linear differential equation. Moving to the next problem, we have this problem here. So let us now solve it. So again, if we put it in the standard form, it will become dy dx plus there should be an x. So it will become sec square x. We are dividing by cos square x, so it will become sec square x here, and there will be another sec square x here also. So first, let us now find the integrating factor. It will become integration e power integration sec square x dx. So it will become e power 10x. So again, we can directly write the solution. So the solution will be here e power 10x integration e power 10x into sec square x into 10x dx. So how can we solve this equation? So we need to substitute. So this part is already solved, and for solving this part we need to use substitution. So if we use the substitution like this, tan x equals to z, it will give, so wait, e power 10x means sec square x dx equals to dz. So this sec square x and this dx part will become dz, and here we can write z and z. So y e power 10x, and it will become this z into e power z dz. So again we need to use the by parts, integration by parts. So it will become this minus ddz of z, again integration e power z dz, and the whole integration. So it will give z e power z minus ddz of z is 1, this term will become 1, and integration of ez is ez, so it will become ez dz. So ultimately it will become e power z minus e power z plus c. So y into e power 10x, and again we have substituted tan x as z, so it will give tan x, sorry, the minus here should be, wait, we should take e power z. So e power 10x minus 10x minus 1 plus c. So this is the solution. Thank you for watching this video. Please like and comment to this video and subscribe to my YouTube channel. Thank you.